Good morning, children. So in the yesterday's class I explained you about the first unit of static electricity. In that we learned about the structure of atom. So we learned how Rutherford gave the postulates about the atomic theory. We learned Rutherford's atomic theory. Correct? So today we are going to learn how do the substance get electrically charged. Okay, we are going to learn how do the substances get electrically charged on rubbing. So I told you when the glass rod is rubbed with the silk, it will get, the glass rod will get charged, and the ebonite rod when it is rubbed with the cat's fur, it will get charged. Yes. So and also I showed you how the balloon got charged when I rubbed it to my hair, and also how the scale got charged when I rubbed it to my hair, right? So, but how does it get charged? How does these substances get charged on rubbing? Okay, now let me explain you. So, already I told you what are called as free electrons. So, free electrons are the electrons which are present in the outermost orbit of an atom, right? They are present in the outermost orbit of an atom. So, the force of attraction is very less, right? So, they are called as free electrons. So, the free electrons are responsible. The free electrons are responsible. So, what is responsible for the substances to get electrically charged? The free electrons. Okay, the free electrons are responsible for the electrification of the body. That is, the free electrons are responsible for the body to get charged electrically. Now let me give an example. Here I have taken a body A and a body B. So now I am not mentioning whether it is a ebonite rod or a glass rod or a comb or a balloon. So we are just considering a body A and body B. So when the body A is rubbed against the body B, the body A, it loses the electrons. So I am taking body A and rubbing with B. So this is body A and this is body B. So I am taking this and rubbing to this. Okay. So what happens? The free electrons which are present in body A, they will move towards the body B. Okay. What will move towards body B? The free electrons which are present in body A will move towards the body B. It clearly means body A has lost the electrons. Correct? Body A has lost the electrons. So it has donated or given the electrons to body B. So this, the person who gives already seems to be good. Right? So for example, if I have 2 chocolates and if I give it to you, so you will feel happy, you will feel, oh, ma'am is very good, right? So I get positive impression. So here the body A is getting positively charged. Body A is getting positively charged, and body B, which has taken the electrons, okay, which has taken the electrons, it will get negatively charged. Okay, so for this I will give you an example. So if you have some chocolates, so if I just grab those chocolates from you, so what will you feel? Oh, that man has taken the chocolates. So you will get the negative impression, right? So here the person who is giving will be positive side, and the person who is taking will be on the negative side. Not always, sometimes children. So the body A, on losing the electrons, it becomes positively charged, and the body B, on gaining the electrons, that is on receiving the electrons, it becomes negatively charged. Okay. So this is called as positive electrification. It is called as positive electrification. So the positive electrification is due to the deficiency of electron or losing the electrons. Positive electrification is due to the deficiency of electrons or losing the electrons. So I told you the positive electrification is due to the deficiency of electrons. So why I am telling due to the deficiency of electrons? Here I told you always, so the number of protons is equal to number of electrons, right? So when this body A is giving the electrons, what happens? So the number of positive charges become more, that is protons will become more and the number of electrons will become less. So the body A will become positively electrified. Okay, so I told you positive electrification is due to the deficiency of electrons. In the same way, this body has received electrons. So it means already here the number of protons and electrons, okay, positive and negative charges, they were equal. But when it has received the electrons, what happens? The number of negative charges became more than the number of protons. Yes, the number of negative charges became more than the number of protons. So the number of negative charges is more here. So the electrons are in excess. Yes, so negative electrification is due to the excess of electrons. Here the negative electrification takes place due to the excess of electrons. Okay, is it clear, children? Okay, let us move to the next topic, law of conservation of electric charges. So let us see about the law of conservation of electric charges. So this law states, so you know the law of conservation of energy. So what does it state? It states the total energy of a system remains constant, right? So in the same way, so it states that law of conservation of energy states that energy can neither be created nor be destroyed. The total energy of the system remains a constant. In the same way, this law of conservation of electric charges states that the sum total of electrons in a system is a constant quantity. So the sum total of electrons in a system is a constant quantity. So what is the meaning of this sum total of electrons in a system that is a constant quantity? Okay, let me explain you. Now let us take the regular example, that is, so this is a silk. What is this? This is silk and this is glass rod. Silk and this is cat skin and it is ebonite rod. So before rubbing silk and glass, they have their own charges. Okay, and now here after rubbing, what happens? After taking the silk cloth and rubbing into the glass rod, what happens? The electrons from the glass rod will get transferred to the silk cloth. Okay, since it is gaining the electrons, so the glass rod becomes positively charged and this silk cloth becomes negatively charged because it has more number of electrons, right? So it already had the electrons, and again from the glass rod it is receiving the electrons. Electrons is nothing but negative charges. Here the number of negative charges have become more compared to the number of positive charges. So it had equal number of positive and negative charges. So after rubbing it has gained electrons, means more number of negative charges. So it became negatively electrified. It has excess of electrons, right? So here the negative electrification took place. And here, so what happens, since this glass rod has lost many electrons, this glass rod has become positively charged. It got positively electrified. Okay, for glass rod, positive electrification has taken place because there are more number of protons than the electrons. Yes. So in the same way, cat skin and ebonite rod. So this is before rubbing against each other. So after rubbing against each other, what happens? So from this cat skin, it gives the electrons to the ebonite rod. So what happens? The free electrons from the cat skin, when it gets transferred to the ebonite rod, so the number of electrons in the ebonite rod have negatively electrified. Okay, so it has the number of electrons is more here, and here, so it has positively electrified. Okay, so this was about, so even though it has some substance has lost electron and another substance has gained electrons, so what is happening here? Totally, when we consider both the bodies, the number of electrons will be same only, right? So either I give 2 chocolates to you or you give chocolates to me. So when we consider both of us, what happens? We both have same number of chocolates, right? Total number of chocolates between us is same. That is 2 only. Yes? Are they going anywhere? No. So it is totally 2 only. In the same way, so here also it takes place. So sum total of electrons in a system is a constant quantity. Okay, let us come to the last topic of this unit, that is conductors and insulators. So in the last year we have learned what are good conductors and what are bad conductors. So what are good conductors of electricity? So the good conductors are those which allow the electricity to pass through them. And so what examples did we learn? So we learned metals like copper wire. Yes. So all metals are most of the metals are good conductors of electricity. And we had learned the materials which do not allow electricity to pass through them are called as bad conductors. Right? We learned wood, plastic, rubber are the examples for that. So now, in terms of atomic theory, let us learn what are conductors and insulators. So here we are going to understand what exactly happens when the electric current passes through the conductors and insulators. Okay children, now I told you there are free electrons in each and every substance, okay, but the point to be noted here is the number of free electrons in one substance may differ from another substance. Okay, for example, I will tell you the number of, so when we consider 1 cubic centimeter of silver. Okay, when you consider 1 cubic centimeter of silver, the number of free electrons is 10 to the power of 23. Okay, it is 10 to the power of 23. But when you consider 1 cubic centimeter of mica, okay, when you consider 1 cubic centimeter of mica, the number of free electrons is very less. It is just 10 to the power of 4. How much? It is just 10 to the power of 4. The number of free electrons will vary from a substance to a substance. Okay, from an element to an element. Okay. Now, actually what happens? Now consider this is a copper wire. This is a copper wire. So now in this copper wire there are some electrons. Okay, so there are some electrons. So these electrons, you know, they won't sit quietly. They will be moving around. So when the electric current is passed through this copper wire, so since it has more number of free electrons, so the large number of free electrons will start moving. Okay, so the large number of electrons will start moving from one end to another end. So this is called as conductor. Okay, so let us look at the definition here. A substance which has a large number of free electrons. A substance which has a large number of free electrons such that they start drifting. Drifting means moving. Okay, such that they start drifting from one end of the substance to other end when it is connected to some source of electricity. So as I explained you, when I connect this copper wire to the source of electricity, since it is a metal and it has more number of free electrons, they start moving from one end to the other end. So this is called as a conductor. Let me tell you once again, a substance which has a large number of free electrons such that they start drifting from one end of a substance to another end of a substance when it is connected to some source of electricity. Then it is called as a conductor. Okay, so examples are all metals, almost all the metals are good conductors of electricity, and also solution of acids in water. When you prepare solutions of acids in water, so even that becomes a good conductor of electricity. You might have learned about electrolysis, right? So that solution of acids in water, and also solution of soluble salts. When you prepare the solution of soluble salts, even that becomes a good conductor. And in the same way, insulator. So it is just opposite to that. So what happens? A substance which has few free electrons. So in the insulators, generally what happens? The number of free electrons will be very less. So even there also the electrons will start moving from one end to another end, but it will be very less number of electrons. Okay. So the substance which have few free electrons such that they do not easily drift. Okay, they move but not easily. They do not easily drift from one end of the substance to the other end. Okay, which when it is connected to some source of electricity, then it is called as an insulator. So what happens? A substance which has a few free electrons such that they do not easily drift from one end of a substance to another end when connected to the source of electricity is called as an insulator. So you know already the examples are wood, plastic, rubber, and so many examples can be given. So it may be sulfur, sealing wax. So you know sealing wax, right? So for sealing purpose they will use. So sealing wax, sulfur, so the wood, plastic, rubber, all these will come under the insulators. Today we learned about the law of conservation of electric charges, and also what are good conductors of electricity, that is conductors and bad conductors of electricity, which are also known as insulators. Okay, so by this we end the first unit of this chapter. In the next class, we will begin with the second unit of the chapter. Thank you, children.